Hello, welcome to our presentation where we want to look at how to find the EIGEN values and EIGEN vectors. Okay. Of a 3 by 3 matrix. Okay. Our question is as follows. Find the EIGEN values and EIGEN vectors. Okay. Given matrix B as 3, 1, 0, 4, 3, 0, or 0, 2. That is how you, so solution. We are going to get our eigenvalues and eigenvectors using analytic methods. Okay, we are using analytic methods. Okay. We are not using numerical methods, right? So we're going to use analytical methods. Okay, so now, for us to get the eigenvalue, we need to come up with a characteristic polynomial. Now, the car polynomial is given by the determinant of b minus lambda I, and this must be equal to 0. Okay, what do we mean? So determinant of 3, 1, 0. The matrix is the 4, 3, 0. I think 0, 0, 2 minus lambda. I is the identity matrix. 1, 0, 0, 0, 0, 1, 0, 0, 1. This must be equal to 0. Okay. What do we have? We're going to have the determinant of 3 minus lambda by 1 will be lambda. So minus 3, 3 minus lambda. Then we have 4. We have 0. Lambda by 0 will be 0. So we have 1. Lambda by 1 is lambda. So we have 3 minus lambda. Then we have 0. Then it will be 0. 0. Then 2 minus lambda. The answer is what? 0. Then we know that we need to get the determinant of this 3 by 3 matrix. There are a lot of methods. So using this first. So I'm getting rid of this, the first row and first column there. So I'll have 3 minus lambda. Then I should find the determinant of 3 minus lambda, 0, 0, 2 minus lambda. All right. Then I move to this one. So temporarily we will remove that. So to be minus 4, we're using plus, minus, plus. Okay. And you have 1, 0, 0, 2 minus lambda. Now, since the last one is 0, when you multiply, if you say 0 and you put something here, it will be 0 here. So we can just leave out this part. Okay. Yeah. This is what we have. Okay. What do we get? You're going to get 3 minus lambda times 3 minus lambda, then 2 minus lambda minus 4, 2 minus lambda is equal to 0. So upon simplification, what do you get? You get lambda to the power 3 plus actually this would be minus 8 lambda to the power 2 plus 17 lambda minus 10. The answer is 0. So this is our characteristic polynomial. So that is a starting point in getting the eigen values and eigenvectors. Now, solving the car polynomial by any method. This is synthetic method. Okay. You can solve this. Our lambda will be 1, 2, and 5. Therefore, the eigen values are 2. We start with 1, 1, 2, and 5. Okay. So now we need now to find the eigen vectors. Now, to do that, to find the eigenvectors, we use this expression B minus lambda I x, and this must be equal to 0. Okay. Now, when you apply that, we can go back. What did we get? Our B minus lambda Our B minus lambda was 3 minus lambda, 1, 0, I think 4, 3 minus lambda, I think there was 0 here, 0, 0, 2 minus lambda. So this by x1, x2, x3, because we have got a 3 by 3. This will be equal to, if you want, you can say 0, 0, 0. Okay. This is what we're going to be using to get our eigenvectors. Now, when lambda is equal to 1, what do we get when lambda is 1? So this implies that we are going to say 3 minus 1, we have 2. 4, 0. 1, 2, 0. Then 0, 0, 0. So we have x, x1, x2, x3. And this is what? 0, 0, 0. Okay. So if you use these two, if you use this one and this one, you see that x1, x3 is 0 throughout from here. Okay. We're able to see that x3 is 0. So it therefore means that from here, our x3 must be equal to 0. Okay. Then, how about x1 and x2? So we can use either the first or second, whichever equation you're comfortable with. Maybe we say 2x1 plus 4x2. The answer is 0. So dividing throughout by 2, we have x1 plus 2x2. This will be equal to 0. So maybe we say x1, we express x1 in terms of x2. So this will be negative 2x2. This is what we have. So now, our eigenvector, our vector, is supposed to be x1, x2, and x3. So what is our x1? Our x1 is negative 2x2. What is our x2? It is x2. And what is our x3? Is 0. All right? Therefore, or maybe before we conclude, we can say our V is equal to, if we factor out this x2, so we have x2 here, negative 2, 1, and 0. So this one now is our eigenvector. Take note, this is 2. Therefore, our V1, our first eigenvector is negative 2, 1, and 0. That's what we have. Okay, I get the second eigenvector. When lambda is equal to maybe 2. Okay, so from b minus lambda I is equal to 0, what are we going to have? You can pause, maybe give it a try. Okay. From that, if you can check, this implies that actually we can even say from this. Okay. When we're coming up with this expression. Okay. Yeah. So we can even maintain that. But as an equation, for us to come up with equations, we can do this here and say x is equal to 0. I think this would be better. So what is this part only? When you put 2 where there is x, so to be the first one would be 3. Let's go back here. Here, if you put 1 here, if you put 2 rather here, we are going to have 1 here. Here there will be 4. Everything will not change apart from where there's lambda. So if I put 2 here there will be 1, and there will be 0. Okay. So what are we going to have? We are going to have 1, 4, 0, 1, 1, 0. Then we have 0, 0, 0. X1, X2, X3, 0, 0, 0. Okay. What do we do? If we want, we can apply some row operations. Okay. Can apply some row operations. But from here, since we are saying 1 plus 1 is 0, that is x1 plus x2 is equal to 0. From this statement, okay, it simply means x1 must be equal to what? 0. X2 must be equal to what? 0. All right? Alternatively, we can say, maybe we do some row operations so that it can be followed. Row operations. Okay. The aim is to come up with a matrix of this nature, if it will be possible. All right? Yeah. So, for the first one, maybe we can say we want to remove this. We want to make that 0. Okay. How do we do that? So we'll say row 2. We imply that maybe we say row 2 itself minus row 1. So this means that we'll have 1, 4, 0. 1 minus 1, 0. Here there will be there will be -3, 0. Okay. Then we have our 0, 0, 0. Okay, applying the operation on the matrix. Next, we can make sure that here there is 1 here. So we say row 2, imply that. May we just divide this. Row 2 itself, negative row 2 by 3. We multiply by -1, then divide by 3. So this will imply that we have 1, 4, 0, 0. So when you multiply by -1, it will be 3 by 3 will be 1, then 0. So we have 0, 0, 0 here. Then we want this to be 0 as well. So we'll say row 1 is equal to, maybe we say row 1 itself minus 4 row 2. Okay. So what do we get? We have 1. When you say 1 minus 0, you have 1. Okay. So what we're saying is that our row 1 is 1 minus 4. Row 2 here is 0. So it will be 1, which is this one. Right? Then for this one, it will be 4. That is row 1 minus 4 row 2, which is 4. So the answer will be 0. Here there will be 0. Actually, here there will be 0. So 1 0 rather, 1, 0, 0, 0, 0. Okay. So now this simply means now we have as our equation 1, 0, 0, 0, 1, 0, 0, 0, 0, x1, x2, x3, 0, 0, 0. Okay. That's what we are going to have. So from the first one simply means x1 is equal to 0. All right. Then from the second one, it simply means x2 is equal to 0 as well. Okay. Therefore, our EIGEN vector, it should be given in this form. x1, x2, x3. So x1 is 0, x2 0. Then we have our x3 here. Okay. So v is equal to 0, 0, 1. If we take out the 3 here, x3. Therefore, our v2 is equal to 0, 0, 1. Okay. This is our EIGEN vector. Now, when lambda is equal to 5, what is your EIGEN vector? Okay, give it a try and compare with what I found. Give it a try and compare with what I found. I found V3 to be 2, 1, 0. Okay. Then on your own, you can try now find the eigenvalues, eigenvectors of this matrix. 3, 3, 0, 3, 5, 0, 0, 0, 6. But the eigenvectors, when you are done, they may come out to be like this that I found. Okay, so I think V1 may come out to be negative 1.3, 8, 7, 4, 1, 0. V2 may come out to be this. V3 it may come out, let me check what I got. 0.7207, yeah, maybe 0.8 when we round it off. 1, 0. Give it a try and see. You can comment and let me know what you're going to find. Please subscribe to our channels, Kanban, phiri-JM. Chaomba Mbondo. In case you want to contact us, those that are doing the GCE, can contact us on 0978 56 58 58 58 76. Till next time, bye-bye.